All right, guys, so we're going to graph a sine graph and a cosine graph. No video for the first couple of booklets. One is a review on how we deal with our equations, and then the second one introduces you to the base graph for a sine and a cosine graph. We get all of those points from all the old table stuff that we did, like root 3 over 2 and root 2 over 2 and all those things. So go through those notes first. Make sure that you understand kind of where the base graphs come from, and then it gets into things like amplitude and other things that will be discussed in this video. So hopefully that it's a good review for you either way. All right, so we have y is equal to 3 sine of 2x plus 1, and the expectation is that we need to graph this graph. Here's how we'll always split up our questions. We're going to have it with some info for the y-axis here on the left, some info for the x-axis, and then other info that's going to be really important to our question. And we're going to set it up the exact same way for sine and cosine. So first thing I want us to find is the amplitude for the question. Okay, and that comes directly from the equation. Let's just make sure that's not completely off the screen. Okay, so the amplitude in this question is equal to 3. Remember from the second booklet that amplitude is the magnitude of this number or the absolute value of this number. So I don't care if it's -3, I would still just put +3 for the amplitude itself. We'll deal about a being positive or negative a little later. Okay, so the second thing that we're going to get is something called the sinusoidal axis. Okay, that's a fancy term for where is our middle point, okay, and our middle line, I should say. And our middle line in this question is always going to be the k value, okay? So in this case, the sinusoidal axis is equal to +1. And finally, the last thing I'm going to get, and it deals with both of these together, is I'm going to get my max value in the y direction and my minimum value in the y direction. And that is always going to come from the sinusoidal axis in the middle plus or minus the amplitude, okay? So the max in this case is going to be 1 plus 3, which is 4, and then 1 subtract the amplitude, oops, no it is 3, I had 4 in my brain, so 1 minus 3, which is -2. Okay, so what I'm going to do now is I'm going to draw out my tick marks for y. I'm going to go 1, 2, 3, 4. And for full marks, make sure you just label your max and min values on the graph. And then that way I know what your scale is equal to. And I'm also going to draw in a dotted line. Remember that dotted lines assume that we have no answer to the graph. They're just there as a reference point, whether it's for asymptotes or other things later in the year. But I have my sinusoidal axis at y equals 1. That is now the midpoint to my graph. Okay, so that was the y-axis information. I'm just going to give myself a little more room here for the x-axis. First thing I want us to talk about for the x-axis is the period. Okay, the period of the question, if you remember from the last booklet, is when does our graph repeat itself? We get period from the equation 360 divided by b, and I don't care if b is positive or negative. If it was equal to radian measurements, then I would go 2 pi divided by b. So in this case, the period measurement is 360 divided by the 2 value there, and the period in our question is equal to 180 degrees. Now that doesn't mean anything just yet, but what that's going to allow us to do is it's going to allow us to take the period measurement and give us the scale for the x-axis. The scale for the x-axis is always going to be the period, and we're always going to divide that value by 4 for every single question. It's kind of like a mini formula. So in this question, it's going to be 180 divided by 4, which is 45 degrees. So that means every tick mark that I do on my x-axis for the graph is going to be 45, and then it's going to make its way up to 180, etc. So every tick mark here is going to be 45 degrees. As long as you label for me the beginning point and the end point, that's acceptable for the labeling there. So that's what we need for the x-axis. Finally, there's some other pieces of the graph that I need to consider. Okay, number 1, what graph do I have? I have a sine graph, and I know that this graph starts in the middle. Okay, Starting in the middle means we start at the sine axis, the sinusoidal axis. Remember from the base graph that you would start at 0, which is right in the middle of the graph, and then go up to the maximum, down to the minimum. So in this case, we are going to start in the middle as well, but before we draw that dot, there's two other things I need to note for my graph. I also need to note whether I have a phase shift or not. Phase shift is always the h value in our question, which in this case we do not have any phase shift. We will see it a few more times in the rest of the booklet. So if the phase shift was something like 45 degrees, I would not start here, I would start over here at 45 degrees. And the last thing I need to note is whether my a value is positive or negative. That means that my first line is going to go up to the maximum value, because on a normal sine graph I go from middle up to the max. If the a value is negative, I would go from the middle down to the minimum. Okay, it would flip my graph over. So here's my starting point. So let's draw a dot at 0, 1. Then I'm going to go up to the maximum value at the next tick mark, which is 45 degrees, and the max is 4. Then I go back to the middle. Then I go down to the minimum. Then I go up again to the middle. Okay, and that all comes from your base graph. Your base graph goes middle, max, middle, min, middle every single time. And that's exactly what we will follow in these graphs as well. Okay, so that is how we draw our sine graph. And because there is no domain, I'm going to put arrows on each end. If the domain said something like 0 to 180, then I would put solid dots at the starting and ending point, and then I would leave it at that. So pause the video if you need to. Try example 2a for your sine graph, and now we're going to move towards a cosine graph with a little bit more information. Okay, so we are going to now do example 2c in your booklet. So you can do a and b based off the sine graph. Now we're going to do cosine, which in this case is 4 cos 2 bracket x plus pi over 4 bracket plus 3. Just a note that we haven't seen yet, and you will see later in the booklet, we need to make sure that this is fully factored, which it is. So if anything was attached to x, remember that we have to factor it out for the question. We're going to start with the y-axis, which has an amplitude of positive 4. It's always positive. If this was negative 4, I would still put positive 4 there. The sinusoidal axis is equal to 3. Okay, the sinusoidal axis is y equals 3 because it's always the k value. That means that my maximum value is 3 plus 4, which is 7, and my minimum value is 3 minus 4, which is equal to negative 1. So now on my graph, I have a max at 1, 2, 3, 4, 5, 6, 7. Just extend that graph a little. And then we have the minimum at negative 1. So negative 1 and 7 I'm going to label, and I'm just going to put a dotted line at the sinusoidal axis. Okay, it gives me that midpoint. The x-axis, I need to know the period. In this case, that is 2 pi over 2, which is equal to pi. Okay, remember period is 2 pi or 360. In this case, it's in radians. And then in this case, for the scale, I'm going to go period divided by 4. That can't reduce anymore, so the scale of my graph is just pi over 4. So when I draw my tick marks here, I am starting at pi over 4. Pi over 2 would be the next one. 3 pi over 4 would be the next one, and we end at pi. I'm okay if you just label pi over 4 to pi in that case, unless the question asks you to label them a little bit more. How did I get those? Remember, we go pi over 4, then 2 pi over 4, which reduces, 3 pi over 4, and then 4 pi over 4, which reduces to pi. Okay, you're just counting up by ones in the numerator. Otherwise, what else do we need to know? We know that a cosine x graph is going to start at the max for a normal graph. A is positive, so in this case, we also are going to start at the max. If it was negative, then this graph would start at the minimum. Okay, it would flip our graph completely, but because A is positive, we're going to start at the max as well. Phase shift in this question is equal to negative pi over 4. Remember that h values are always flipped. And now we know that we can start here at the maximum value. Oh, my apologies. We are not going to start there. Forgot about the phase shift that I just mentioned. So let's put negative pi over 4 here. Okay, works out nicely, so we put a dot at negative pi over 4. So we still start at the maximum, but we are starting at the phase shift of negative pi over 4. You go down to the middle at the next tick mark. You go down to the minimum at the next tick mark, and then we continually make our way along the graph. Middle max, middle again, and now I can kind of get a curve here, go through the middle, curve there, up to the max, down to the middle. Again, there's no domain in this question, so I'm going to put arrows at the top and on the bottom. If the question said something like negative pi over 4 to pi, I would stop my dot at negative pi over 4 and stop my dot at pi. If it's extended in any way, let's say it wanted negative 2 pi to pi, just keep your tick marks going along and then just continually add in dots as you go through, and that should hopefully help you with example 3 as well.